Hello, good evening. The topic which I have selected today for the video lecture, that is simplification of algebraic fractions. In this video lecture, I have selected four algebraic fractions and I'll solve them by according to the mathematics rule one by one. So the first algebraic fraction which I have selected, that is, let me write it. So the first algebraic expression, that is s 5 divided by 2s plus 4 and minus 3 divided by s square plus 3s plus 2 plus s divided by s square minus s minus 2. As we know that in this questions there are three algebraic fractions. One is this one, second algebraic fraction, and third algebraic fraction. So according to rule of mathematics, whenever there is plus and minus in between two algebraic fraction, the procedure which we adopt, that is LCM. So first of all, we will find the LCM of all the denominators of every algebraic fractions. But before going to find the LCM of these three denominator, so let me factorize first. As this one, the first one has been already factorized, just we can take a common 2 as a common, and the second is written in quadratic form, that will be factorized because we need two factors in order to take the LCM as an easy step. And third, also we have been given the quadratic equation. So the third quadratic equation will also be factorized, because in these three factorization we will have some common and non-common factors, because LCM can be taken from both common and non-common factor. So let me proceed it. First of all, I'll write the question in this form, that this will be 5 divided by, so 2s plus 4, because in these two terms we can have the 2 as a common, so 2 can be taken as a common, so it will become 2s plus 2. In the second one, minus 3 divided by, we have s square plus 3s plus 2. Since we know that this is a quadratic equation, so according to rule of factorization, the constant term will be multiplied with the quadratic term, so it will become 2s square. The middle term, I mean 3s, it will be split into two terms, and that two terms when added or subtracted, so the result should be 3s, and if they are multiplied, the result will be 2s square. So let me split the 3s, it will be written like this: s square plus 2s plus s plus 2. Similarly, because we know that when 2 and s, or 2s plus s are added, so it will become 3s, but when they are multiplied, so it will become 2s square. Thirdly, plus, it will become s divided by s square minus s minus 2. It is also a quadratic equation, so it can be also split into two terms. I mean the middle minus s will be splitted, so it will become s square minus 2s minus s and minus 2, because when minus 2s plus s, sorry, it will become plus s, minus 2s plus s, so the result will be minus s, but when these two are multiplied, the result will become minus 2s square. So in the next step, again I'll write 5 divided by 2 into s plus 2 minus 3 divided by, here in these four terms, in the first two terms the common thing is s into s plus 2. So in the second one, s and plus 2, the common is plus 1, so it will become s plus 2. Next step, plus, so in the last algebraic expression we will have s divided by s square minus 2s, so s is common, remaining will be s minus 2, and in plus s minus 2 plus 1 is common, so let me have a space, plus 1 is common, so another will so in the bracket we will write s minus 2. So in the next step I'll write all the terms in one form, so it should be written like this. Let me proceed it. So 5 divided by 2 into s plus 2. In this question it is very necessary to write all the denominator quadratic equation in a factorized form, because if they will not convert into factorization, they will not be written in a factors form, so we are not able to find the LCM of common and non-common factors. So if before taking the LCM, it should be converted first into factors form. So as I am converting them, minus then 3 divided by, so s plus 2 and s plus 2, it will be taken as a common, so the remaining term is s plus 1. Similarly, plus s divided by, so s minus 2 can be taken as a common, so the remaining is s plus 1. Now it is very easy to decide what should be the LCM of all three denominator, because we already know that the LCM of any number can be, any number or algebraic expression can be taken as a common factor and non-common factor. So it is easy to take the LCM. In the first polynomial, s plus 2 is available. In the second polynomial also s plus 2 is available. So these two can be taken as a common. So let me write them s plus 2, because it's common in both polynomial. So we take one factor as a common. Similarly, s plus 1 and s plus 1 all also common, so they all should be, they both should be taken as a common. Similarly, s minus 2 and s plus 2, uh, just let me check, it is s minus 2 or it should be s plus 2, because we have to take the same, no, sorry, s plus 1 and s minus 2. S minus 2 is non-common factor, because these two, s plus 2 and s plus 1, are common factor, so s minus 2 is non-common factor. One another thing that is non-common, so 2 is also non-common factor. LCM is equal to common factor and non-common factor. So these two are common factor, whereas s minus 2 and 2, these two are non-common factor. Now how to write the question in numerator? In numerator, whenever we have to take the value, the procedure is this whole denominator divided by this denominator. So 2 will be cancelled with 2 and s plus 2 will be cancelled with s plus 2. Remaining 2 factor will be multiplied with 5, s plus 1 and s minus 2. So it should be written like this: 5 into s plus 1 and s minus 2. Similarly, minus 3 multiplied it by, in the second step also, the whole denominator divided by s plus 2 and s plus 1. So s plus 2 will be cancelled with s plus 2, s plus 1 will be cancelled with s plus 1. The remaining 2 factor, 2 and s minus 2, will be multiplied with a 3. So 2 into s minus 2. Similarly, plus s into, again this denominator complete, this complete denominator divided by these two. So s minus 2 will be cancelled, s plus 1 both will cancel, so the remaining factor are 2 and s plus 2. So 2 into s plus 2. Now write the denominator as it is, but simplified the numerator, so some terms may be cancelled, so whatever will remain, that will be your answer. So let me go to the next step. It will become like this. So 5 into s plus 1 and s minus 2, these three will be multiplied, so it will become 5 into s square minus 2s plus 1 into s, and plus into minus 2 into 1 2. So in these four terms 5 will be multiplied. Again minus 3 into 2 6. So 6 will be multiplied with s minus 2. It will become 6s. Bracket is important because minus changed all the sign of all the remaining terms. So 6s minus 6 into 2, it will become 12. Similarly, next step will become 2 into s will be multiplied with s plus 2. So 2s square. Here bracket is not necessary because plus has not the property to change all the sign of the remaining terms. So 2s square plus 4s and divided by whatever is written in the denominator, so write it as it is. So in the denominator we will write divided by, it will become 2 into s plus 2, s plus 1, and the last one factor is s minus 2. So now go further in order to simplify the numerator. So it will become 5s square, I'll write like this, 5 into s square minus 2s plus s, it means minus s, and minus 2 into minus 6s, minus into minus plus, it will become 12 plus 2s square plus 4s divided by same denominator as it is. So let me write it. It will become 2 into s plus 2 and s plus 1 and s minus 2. Now with the first quadratic factor, just multiply this 5, then simplify. So it will become 5s square minus 5s minus 5 to 10 minus 6s plus 12 plus 2s square plus 4s. Now all the same power variable terms will be added or subtracted. So let me come to write the denominator as it is. So it will convert like this: 2 into s plus 2 and s plus 1 and s minus 2. Now in the above numerator we have 5s square and 2s square, so both will be added, so it will become 2s square. Let me write it: 7s square because the coefficients are added. Second, minus 5s and 4s, and also 6s. Minus 5 and minus 6, it will become minus 11s, but minus 11s plus 4s, it will become minus 7s. So the remaining term is only minus 10 and 12. So 12 minus 10 will become 2 divided by, this was the simplified form of numerator, so in division write it as it is. So 2 into s plus 2 into s plus 1 into s minus 2. This is the simplified form of this algebraic fraction, because further it cannot be simplified even if we will make a factorization of this quadratic equation. So same factor will not arise as s plus 2, s plus 1, s minus 2. Even if we will make a factorization of the above numerator, if the factor same like s plus 2, s plus 1 and s minus 2 will arise in the numerator, so they will be cancelled. But I hope in the above numerator, even if after factorization, we will not have such a factor as available in the denominator. So this is the end of this algebraic fraction. So let me explain one more example regarding this topic. So the another example will be like this: x square minus 4 divided by xy square multiplied it by 2xy divided by x square minus 4x plus 4. In this algebraic fraction, it is not necessary to make LCM, because here in this question the plus and minus sign is not available. Okay, in this algebraic fraction, as we know that here in the middle multiplication sign is there. So whenever there is a multiplication sign, we have the only possibility in order to solve such type of question, that is multiply the numerator with the numerator and multiply denominator with denominator. But before multiplication, if there is any terms available in the numerator, even in denominator, which are same, they can be cancelled. Just like in this question, we can have y square in denominator and y in the above. So one y from denominator, one y from numerator will be cancelled. One x from denominator and one from denominator, so these two will be cancelled before factorization. Now because these are in same form, one is in numerator and second is in denominator, so they both will be cancelled. So now we have one formula: x square minus 4 multiply by 2. Let me write it, that how we can write in this these two in which form. So x square minus 4 can be written as x square minus 4 can be written as x square minus 2 square, because we have one formula, that is a plus b and into a minus b, and that is equal to a square minus b square. So as 2 is multiplied, so let me write to it as here. Secondly, in the denominator only y is available, so y can be written as it is. Secondly, we have a quadratic equation, x square minus 4x plus 4. Same quadratic equation is available in numerator as well as in denominator. But if we will factorize them, here may be a similar factor, so they both will be cancelled. So whatever will remain, that will be your answer. So let me write it in the another step: 2x square minus 2 square. The formula I already explained, that is 2 into x minus 2, because one time in minus and one time in plus, so x plus 2, because a square minus b square can be written in this form. Then divided by y into x square minus 4x plus 4. This one is a quadratic equation. So we can factorize this equation. We will multiply 4 into x square. So the answer is 4x square. So 4x square can be written in a separate place, or even you can keep in mind also. Now we have to split minus 4x in two terms whenever they both are added or subtracted. So the answer should be minus 4x. But if when they are multiplied, the answer should be 4x square. So let me write them. X square minus 2x minus 2x plus 4, because minus 2x whenever added, so the answer is minus 4x, and whenever they are multiplied, the answer will be 4x square. So let me proceed it again. I'll write the question in this form: 2x square 2 into 2 into x minus 2 and x plus 2 divided by, write y as it is. Then in the first two terms, x square minus 2x, x is common, so the remaining will be x minus 2. In another two terms, one is minus 2x, another is 4. In these two, minus 2 is common, so x minus into minus will be plus, 2 into 2 will be 4. So because it should be close, because y has is in a multiplicative form with all the terms. So in the next step, I'll write it like this. Again, 2 into x minus 2 and x plus 2, because there may be similarities, similar factor, even both in numerator and denominator. So in the denominator we will have y into x minus 2 and x minus 2, both are common, so it should be written like this. And x minus 2, another x minus 2, they both are common. So now we are having a factors in numerator and denominator, and the only factor that can be cancelled from even both numerator and denominator, that is only x minus 2, x minus 2, because the remaining are not possible to be cancelled. So the remaining complete answer of our this question is 2 into x plus 2, because further it is not possible to be simplified, and y into x minus 2. So this is the complete answer of this algebraic expression. So this type of explanation can be further explained one by another example. So let me proceed to go to another example to solve such type of questions. Next question is, that is already written in the factors form in denominator. So we can easily find the LCM of denominator. I mean to say that the denominators are not written in a quadratic form, they are written in a factorized form. So we can easily find the LCM of denominator. Let me write the example, then I'll solve step by step. A divided by c minus a into a minus b, these are two factors. Then plus b divided by a minus b and b minus c, these are also two factors. Then plus c divided by b minus c, and the last factor is c minus a. As I explained already before, that the denominators are already written in a factors form, not in a quadratic form. So now the question arises that we have one algebraic fraction plus second algebraic fraction and plus third algebraic fraction. Whenever we have algebraic fraction and in between them there is an operation of plus and minus only, then the only process which we have to adopt, that is to find the LCM of all denominators. So now we can easily have the LCM of all the denominators. The LCM can be written as like this, because we have to we have to choose the common and non-common factors. So the LCM of denominator will be like this: c minus a and another c minus a is available. One is c minus a here and one is in the last. It means in the first polynomial c minus a is available, whereas in the third polynomial c minus a is also available. So c minus a can be taken as a common. So let me write c minus a, because this is a common factor. Similarly, a minus b and a minus b, one is available in the first polynomial and the second is available in the second polynomial. So we can also have a common a minus b, and the third one b minus c, which is available in the second polynomial, and b minus c, which is available in the third polynomial. They both can be written as a common, so it will become b minus c. Whereas these all three are common factor and the non-common factor is only one. You can write if you want, if you will not write, no matter, but the common and non-common factor are only these three. Now before going to proceed, the process is this whole denominator divided by a minus b and c minus a and a minus b. So c minus a will be cancelled with c minus a, and a minus b will be cancelled with a minus b. The only factor will remain, that is b minus c. So b minus c will be multiplied with the numerator. In numerator we have only a, so it will become b minus c multiplied it by a. Then we have the sign of plus, and in numerator we are having only b. Now this whole denominator divided by a minus b and b minus c. So a minus b and b minus c will be cancelled. The remaining factor is c minus a. So c minus a will be multiplied with b, c minus a. Similarly, in the last we have plus sign and the numerator is c. Again same process we will have to follow. Uh, this denominator divided by b minus c and c minus a. B minus c will be cancelled with b minus c, and c minus a will be cancelled with c minus a. The only factor which will remain, that is a minus b. So a minus b will be multiplied with this c, a minus b. Let me write the whole question in another step. So simplify it. Some terms may be cancelled, so at the end you will have your answer. So let me write it again. It will become like this: a multiplied by b will become ab minus a multiplied by c and ac. Similarly, plus b multiplied by c, bc minus b multiplied by a, ab. ab and ba we can have both, because commutative law is adopted, follow. No matter whether you write 2 cross 3 or 3 cross 2, the answer will be 6 in both the cases. Similarly, plus c minus c into a, या a into c, and minus b into c, and divided by, same you can write the factors, c minus a into a minus b and b minus c. Now b minus c. Now in denominator we are having only three factors, but in numerator I think there is possibility of cancelling some terms, because the sign of some terms is positive, whereas the sign of the same terms is negative. So both terms with different signs can be cancelled. For example, here we have AB first, that is positive, but this one is negative, so both will be cancelled. a into c, that is minus, and a into c, that is plus, will be cancelled. B into c, that is plus, and b into c, that is minus. So all the terms are cancelled in numerator. So in a numerator we are having only 0, whereas in denominator we have some factors. So let me write it: 0 divided by all these numerator. But there is one rule in mathematics, that 0 divided by something is again 0. It means, you can also check in calculator, whenever 0 is divided by any number, the result is again 0. But one thing that is opposite of it, when something divided by 0, so the calculator will not give you any answer. It will be written on the screen that math error, because something divided by 0 is not possible, that the answer does not belong to the real number, because it goes to infinity. So on the screen of calculator or in your laptop, you will have the term that is math error, because it should be kept in mind always, that 0 divided by something will give you some answer. The answer will be exactly 0. But when something is divided by 0, so the answer is math error. So this was another question related to simplification of algebraic fractions, whether we have plus and minus sign in between algebraic fraction, because in plus and minus sign we have to follow the process of LCM. But whenever there is operation of multiplication in algebraic fraction, then we have to adopt the multiplication of all the numerator divided by multiplication of all the denominator. But whenever if there is possibility of cancelling any terms or any variable, any constant even, then we can cancel them before going to solve. But if now I'm going to solve another question in which there is the fourth operation, that is division in between two algebraic fraction. So I'll tell you the steps, that which method and procedure should be adopted whenever we have a process and operation of division in between two algebraic fraction. So the operation of minus plus, operation of multiplication, as I explained in this video lecture. But the last one I'm going to explain whenever we have division in between two algebraic fraction. So let me proceed. First write a question. The question is a cube minus b cube and divided by a power 4 minus b power 4. Then we have sign of division, then a square plus ab plus b square and divided by a square plus b square. In the left side of division side, in both numerator and denominator we have two formulas, whereas on the right side of the division side, neither in numerator nor in denominator, they both are not formulas, but these quadratic factors are available in the algebraic fraction of the left side of division sign. So these two formulas I'll expand. So this term, this factor is also available in algebraic fraction, and same this factor is also available. So in every step I'll expand these two formulas, but I'll write these two factor as they are, because they are not formula, they cannot be expanded. But we are having such type of quadratic factors in a cube minus b cube and a power 4 minus b power 4. So whenever I'll write them, they will be cancelled, so we will have to reach to the final answer. So let me proceed this question. A cube minus b cube, this formula we already know, that a cube minus b cube is equal to a minus b into a square plus b square. Whenever we have minus, so here we will have a sign of plus first and second, so a into b, and divided by we are having a power 4 minus b power 4. So it should be written as like this: a square whole square, a square whole square minus b square whole square, because a square minus b square or is a formula, so we can split them, and we can also write them in the form of two factor, one in the plus and one in the minus. So then we have division sign. Now the process, whenever we have division sign before any algebraic fraction, we have to follow the steps of rule mathematics, that is convert this division into multiplication, and then the remaining algebraic fraction coming after the division sign, that will be written in a reciprocal form. What does reciprocal means? Reciprocal means your numerator will become denominator and your denominator will become a numerator. So the above term will go down, so it should be written like this: a square plus b square and divided by a square plus b square plus ab, because this is the rule that division is always converted into multiplication, but after division whatever the algebraic fraction is coming, that should be written in a reciprocal form. Now we are having two factors that is completely same, one is available in numerator but other is available in denominator, they both can be cancelled. This quadratic factor will be cancelled with this quadratic factor, because both are same and in between we have sign of multiplication. It is possible to cancel both because they are same with all respect, and one is available in numerator and second is available in denominator, so they both can be cancelled. So let me proceed what should be written in the next steps. So in the next step we are having a minus b, then on the other side we are having a term a square plus b square, a square plus b square, whereas in denominator we have a square minus b square formula, so it should be written like this: a square plus b square, one in the positive and one is negative, a square minus b square. Now a square plus b square even available in numerator and denominator, because they are not formula, they cannot be simplified, they cannot be further expanded, so both will be cancelled. As I explained in the earlier, that in this question on the left side of the division sign we are having two formula, one is in numerator and one is in denominator, but on the right side of the decimal sign there is no formula, only two quadratic factors are written which are available in the left side algebraic fraction. Whenever we will expand the left side algebraic fraction, these both factors will be available, I mean quadratic factor will be available in the left side algebraic expression, then both will be cancelled. So as one was cancelled in the first step and second in the second step, now remaining terms are a minus b divided by a square minus b square. We are also having one more step, that will be a minus b divided by a square minus b square, can also be written in this form: a minus b into a plus b. So both factors are available, one is in a numerator and other is in denominator, because they both are also same, they both are also cancelled. So whenever they are cancelled, the remaining term is that in a numerator we are having only one, whereas in denominator we are having a plus b. So this was the simplification of algebraic expression whenever we have positive, negative, division and multiplication sign. I mean in these four operations whenever available in any algebraic fractions in between any two or any three, then the process which we have to follow, let me summarize it: whenever in between two or more than two algebraic fraction we are having the operation of plus and minus. The only process which we have to adopt, which we have to follow, that is to find the LCM of denominator. But whenever we are having sign of multiplication in between two or more than two algebraic fraction, then if possible cancel the numerator and denominator, even variable, factor or any number. But if there is no possibility of cancellation, neither in a numerator nor in the denominator, then think about there might be any factor which we can cancel. But if there is no factors available for cancellation, then the factor might be written in a linear form or maybe in quadratic form. So follow the rule of factorization. Convert the quadratic factor into linear factor. There, after factorization, there is possibility that any number or single variable or the variable of power 1 or even a linear factor may be available in the numerator and denominator, so you can easily cancel them whenever the possibility of cancellation finish. So that is your complete answer. In the next, whenever you are having the only division sign in between two or more than two algebraic fraction, then the process which you will have to follow, that write the left side algebraic fraction as it is, but convert the sign of division into multiplication. But after multiplication, whatever the algebraic fraction is coming, just make a reciprocal and convert the numerator into denominator and denominator into numerator. So just make a reciprocal. Then after reciprocal, it means you converted this operation of division into multiplication. So then you can solve a question by the process of multiplication, as you have explained before. As I explained before, that these four operations whenever available in between two or more than two algebraic expression, so you can follow the rule of mathematics in order to solve and make them in a simplified form. So this was the lecture about simplification of any algebraic fraction whenever in between them these four operations are available. Maybe only one is available, maybe all of them are available, so you can easily solve them completely with correct answer. That's all for today. So have a nice day.